Ampere's law allows us to calculate the magnetic field. So here, if you have a wire like this, and you want to map magnetic field, if there is no current, then a compass needle will point in the same direction. But once you have some current going into the wire, so now you have a field line. You apply the right-hand rule. In this case, the thumb represents the current, so the curling of the four fingers will determine the direction of the magnetic field line. So the compass needle will change its direction this way, and from the direction of the compass needle, we can map the magnetic field lines. Okay. The magnetic field depends on the value of current and on the distance, how far we are from the wire. In general, B equals mu naught I divided by 2 pi r, and the mu naught is called the magnetic permeability of free space. It is a constant, a universal constant. For the SI system of unit, it is equal to 4 pi by 10 to the minus 7 Tesla meter per ampere. I is the current in amperes, and R is the radius here, the distance between the point and the wire. So using this equation, we'll be able to calculate the magnetic field at any point a distance r from the wire. And we use the right-hand rule, as you can see here, to predict the direction of the magnetic field. We can map the magnetic field using a cardboard and iron filings. You just spray the iron filings here and knock gently on the card. So you will see that the iron filings will arrange themselves in these circular lines, representing the circular field lines. Ampere's law tells us that if you take any closed path, like this closed path, and if you multiply the components of the magnetic field that are parallel to the path, this is the meanest sign, parallel is parallel to the path. If you multiply it by the segment of the path length and add all such products, the outcome is equal to mu naught I. Mu naught, the permeability of free space, and I is the current. So from this equation, we can calculate the magnetic field, okay, for a circular path. Because of symmetry, B parallel has the same value because R is the same R for all points along this circular path, so we factor it out. And when you add up all the delta L, you get the circumference 2 pi r. So B 2 pi r equals mu naught multiplied by the total current. The total current in the loop is just I. So from this equation, B equals mu naught I over 2 pi r. So the result that we use here is derived using Ampere's law.